University. So we are going to organize the workshop on the standard handling procedures of laboratory animals in accordance with the ethical guidelines. So in this pandemic hit situation, when the to-be graduate students and the postgraduates are lacking the laboratory access to train themselves in the animal handling, we felt the need to organize this e-workshop, especially on this theme. And so actually it is truly said by someone that for practical, ethical, and historical reasons, the mouse remains the best creature at biologist's disposal. From hailing from the pharmacy background, we all know the need for the animal studies. So in the lieu of this, I would like to call our senior professor, Dr. Subrat Kumar Bhatta Mishra. He is the senior professor in pharmacology of our Department of Pharmaceutical Technology, School of Medical Sciences, Adams University, to share the idea behind the theme of this workshop. I would just like to call Sir for his thought. Sir, are you here?
Yes, yeah.
Please, sir.
Thank you so much. I can hear. Can you hear me?
Yes, sir. We can hear you.
Okay. Okay. Thank you so much for inviting me for this particular event. The event is on standard handling procedure of laboratory animals in accordance with ethical guidelines. So, good afternoon to all of you, and welcome to this session. As a pharmacologist, actually, this topic is very close to my heart because when we talk about the animal handling and the experimentation in animals, so it is all related to our drug discovery and development process, both in academia and also in the industry. So all of the students, we as a pharmacy students, we know that the drug discovery phases, one of the very important component is the preclinical testing. And in preclinical testing, we use animals for finding out the efficacy, safety, and toxicity of the new drugs. And actually, these animals are actually used because they can save human lives. Okay. Before any drug goes to the clinical trial, all this is tested in the animals to see that those drugs should not harmful to the human. So actually, they are sacrificed. These animals are sacrificed themselves for the sake of humanity, for the sake of human. So in that case, actually use of the animals is very important. Handling the animals in a ethical way or as a humanly is very much important. So there are a lot of guidelines as per the CPC SCA India, and I think many students also read the ethical consideration as per the Animal Welfare Board. So I hope this particular topic will be very much interesting and relevant to our student. And with this, I would like to actually welcome Dr. Ronak and Dr. Assis, who has kindly agreed. And thank you so much for your participation and also means as an inviting speaker to us. So thank you, Dr. Anvesha. You can carry on. Thank you so much.
Thank you so much, sir, for sharing these ideas, sharing the need of this kind of event, especially for the students. So without wasting the time, I would just like to introduce our first speaker, Dr. Ronak Nishamwala. So I will just share the brief introduction about him. So he is a postdoctoral research fellow with the Clint Jones Center for Neurobiology and Stem Cell Research at Menzies Health Institute, Queensland, Griffith University, Australia. He received his medical degree from Sardar Patel University, India, and a Master in Medical Science and Technology degree from IIT Kharagpur. He received his PhD from the Griffith University, Australia. Dr. Nishamwala's main research interests include translational research, regenerative neurology, spinal cord injury, and pain perception. During his master's, He was selected as an international program associate at the Riken Brain Science Institute, Japan, to explore the genetic basis of pain perception and nociception. To pursue his interest in regenerative neurology, he then moved to Australia for his PhD. His PhD work was focused on developing novel surgical approaches for transplantation of 3D cellular constructs to repair the injured spinal cord. This work took place predominantly in the mouse model, with a final aim for its clinical translation. At the end of his PhD tenure, Dr. Reshmwala was offered a position as a research fellow at Griffith University, where he continues his work on developing better translatable, robust surgical approaches for treating spinal cord injury. I would like to invite Dr. Ronak Reshmwala to share his talk with us so that our students, we, the faculty members and the academicians and all the participants present over there, they can learn something about this standard handling procedures and the ethical guidelines and how to do that, why to do that, and when to do that. Over to you, sir, Dr. Ronak. So if you can share the screen as well as you can switch on your video if it's possible. So then very nice
hello.
to all of us. Yeah.
Just give me a second. I'm just sharing my presentation. Can you see my presentation now?
Yeah, sure. It's completely visible.
All right. So I'm just going to start. Yes. Okay. First of all, I'm in Australia, so it's 7 p.m. already. So it's almost end of the week for me. And in advance, I apologize for my voice. I'm having a little sore throat and congestion. It's not COVID, but it's just something seasonal. So if you are having any difficulty in hearing or understanding me, please raise your hand in your interface and we can easily revisit the topic that we have been discussing. And based on the request from Dr. Anvesha, this is going to be an interactive session. So feel free to raise your hand at any point and try to entertain any questions in the middle of my talk as well. So let's start right away. The talk that I'm giving is animals in the medical research. We are focusing on why, when, and what. So you already heard my introduction. I'm just going to show you a little bit of my career path here. The nice photograph that you're seeing on the right-hand side of the screen, that's the top photograph is the university building that I'm working on. The top floor of that university, just above the symbol of Griffith University, is where my office is, right here. And this is the coastline of the beautiful Gold Coast beach that we can see from our office. So it's a nice place to be, and it's a nice place to work from. And as you already know, I'm a postdoctoral research fellow working on the Spinal Injury Project, or SIP for short, at the Griffith University. And if you are more curious about my career path or my academic profile, you can Google my name, Ronak Reshmwala, and check out my Griffith Experts page. And currently, I'm working on the regenerative medicine with a specific focus on spinal cord injury or neurotrauma. The image again on the right-hand side top is the team of researchers that I'm working with. It's a huge multinational team, and we are working in a very deep interdisciplinary way, where we have pharmacologists, cell biologists, molecular biologists, medical doctors, veterinarian surgeons, everyone working together to find a cure for spinal cord injury. And on the right-hand side, lower photo is the logo of my team, which is the Clem Jones Center for Neurobiology and Stem Cell Research. So without wasting more time, let's begin about the animals in the medical research. Now, as Dr. Bhatta Misra already stated a little bit before the talk, we all know why animal models are so important. So there is basically there is a discovery biology. On the left-hand side, you can see in this photograph, this is just basically an example of vaccine research. I'm using the vaccine research as an example because of COVID. There is a lot more research happening in vaccine field lately over the last couple of years. So this is a good example to give at this time, I believe. So basically what happens is there is basic discovery biology research happening, which happens in the laboratory or from the benchtop. It's also called in vitro research. And the aim of this research is to find out the biological, sorry, was there a question?
I guess no. So someone might.
Okay. I'll continue then.
Shonita, you
That's
can
okay.
continue. Sorry
Yes,
for that.
no worries. Right. So the final aim of this biological research, the basic science research, is to use the biological phenomenon, explore the molecular basis behind any biological events, and take it to the clinic so that we can benefit all of the humanity. And that's where the animal models come in. There are small animal models like rodents, such as mice, rabbits, rats, hamsters, etc. And then they progress to the larger animal models, which can be feline or canine, like cat or dogs. And ultimately, we can end up with bovine or swine models, so pigs or cows. And after that, we begin the clinical trials, phase 1, 2A, 2B, and so on. So this is basically where the animal research falls in the whole evolution pathway of any clinical therapy that we see in the market these days. Now, why do we use animals? It's a very important thing because biologically speaking, we are very similar to a lot of different animals. Specifically, if you take mouse, for example, because that's the model that I've been using for the last 6-7 years, we share more than 98% of DNA with mice, which is amazing. And we have so many different disease models available in the animal research as well, because these animals are quite susceptible to a lot of human diseases such as cancer, diabetes, heart disease, and a lot of different infections as well. Now, the biggest advantage of using animals such as mice and rats is that they have a very short life cycle, which means that we can study their entire lifespan within a few months or a year. We can also study the whole phenomenon across different generations. We can study different serial generations in animal models. And this is why it's very important, because we can understand the whole disease process and the disease transmission and the inheritance process. And we can also understand how these disease process interacts with the whole living biological system. Now, as we know that this is not an exact replica of the human body, or it's not a perfect model for humans, but it's the best that we have at hand these days. However, we do have a lot of research happening in developing different alternatives, like more advanced in vitro techniques to resemble the human or the animal model, and computer modeling specifically for drug screening. These days, a lot of molecular screening can happen over the computer models as well. And the other fact of the matter is that a lot of researchers prefer not to use the animals, but almost all of us, we understand that it's an unavoidable necessity. So there are various different purposes why we can use animal models in the medical research. For example, preclinical research or translational research, such as the projects that I have been doing. As I already mentioned, we can use the animals for understanding the disease pathophysiology, which is also called discovery science. Behavioral studies are also very important because we can understand the functional and cognitive processes such as brain deficit, stroke, and different other processes. Now, a lot of environmental scientists are also using animal models to understand the different ecosystems, and they study how the animals behave in the natural habitats, and they simulate their natural habitats as well. We also use animals, as you are aware, training and educational purposes. Now, all of these purposes are very important and very critical and very unavoidable to advance the field of medical science, but ethics and consent, these are very important. No animal research can be conducted without an approval from an appropriate animal ethics committee. I cannot stress this part hard enough, that ethics and consent are really important moving forward, and they're becoming more and more important in the recent years. So let's start up with why, when, and what. So I'll start with the why, of course. So why do we use animals in the medical research? Specifically speaking, in medical research only. So most commonly we use the animals for drug testing, disease pathophysiology, genetics and molecular basis of different therapies or different disease processes. Device testing is another very important field where we can use animals. Therapeutic intervention testing, for example, surgical approaches or any other biomaterials that we may be developing for transplantation or treating different kind of burns or deeper diseases. And finally, the effects of an intervention at tissue, organ, and organism level. We need to understand that before we can put any human being in contact with any new therapeutic approach, which is why we have the animal step before we can start the clinical trials. Now, as I said, this is unavoidable to use the animal model. So why exactly is it unavoidable? It is really, really basically common sense, because we have to simulate different complex physiological events. We can have 1 or 2 different cell lines growing in a petri dish, and we can test different compounds on those cell lines. But when we put the drug inside a body, we need to understand what their pharmacodynamics and what the pharmacokinetics are going to be. And it's virtually impossible to know without having a real live body, because pharmacodynamics literally means what the drug does to the body, and pharmacokinetics is what the body does to the drug. So body is basically implied in the definition of pharmacodynamics and kinetics, which is why we need a live animal system. Then we also need to understand what are the adverse effects or carcinogenicity of any new molecules, safe dose, lethal dose, and translational steps in between, where we have in vitro data and then we translate that to milligram per or gram per kilogram of body weight kind of doses. For that translation as well, we need animal models. And finally, the complex interactions between different physiological systems and the interventional agent. Again, this is another way of saying pharmacodynamics and pharmacokinetics, but this is very critical to understand. And this is why we need the animals. But it's not just this, this way where we use the animal for our benefit. There are very good instances where the animal research has been mutually beneficial. So if you look at the left, the purple table there, we have different dog, monkey, mouse, pigs, rabbits, and rat systems where we have done medical research for very groundbreaking discoveries, such as discovery of insulin, polio vaccine development, rabies vaccine, skin graft for burns victims. CAT scan was first tested on a pig. Then corneal transplants are routinely tested on rabbits, and carcinogen testings are usually preferred with rat model, etc. Now, having said that, there are also very good instances where we have seen different animals benefiting from our discoveries, such as antiviral vaccines. We have dog parvovirus vaccines developed from animal research. Similarly, reproduction research and in vitro fertilization and other developments have led to some really good groundbreaking research and successes in repopulating the endangered species, such as koala in Australia, then panda that you may be aware of. Now, similarly, HIV and AIDS research, whenever we had some breakthroughs in those researches, the first benefit went to the cats, because that was the model that they used historically, and leukemia management system was developed based on that, because the vaccines or the pharmaceutical agents, they were interacting with the helper T cells in the research. Similarly, as you can see in the table, we have several different examples of other animals benefiting, mostly pets, because that's where our vested interests lie. But we do have other instances where this has been mutually beneficial. So it is not just that we use animals for our benefit. We have some examples where we have also benefited animals from their sacrifices. Now, moving on to the when is it appropriate to use animals for research? Basically, the when question usually will address the ethical conundrums associated with animal use. The photo on the right-hand side is of a very good book. If you are interested, you can check your library or something, and it's definitely worth reading once if you are going to do animal work. Now, when is it appropriate? There are very specific guidelines to this, but to put everything in very general context, when no other viable non-animal alternatives are available, when fully compliant with current legislation. For example, different countries have different legislation related to different therapies and different technologies. For example, embryonic stem cells and fetal stem cells are mostly widely not legal for experimentation in most of the countries, except for a few countries like China, and partially some stuff happening in Japan as well. So wherever you are doing the research, your experiment and your experimental design, the whole protocol has to be fully compliant with the current legislation of that country or that region. Similarly, it has to be obviously approved by a local ethics committee. That can be your institutional ethics committee or an independent animal ethics committee. Then the protocols have to be thoroughly and independently peer reviewed. Just because we want to try something doesn't make it okay for us to go ahead and just experiment that on animals. It has to be thoroughly vetted. Now, the 3 R's is another big deal in the ethics field. You may already be aware of the 3 R's, but they are basically replacement, refinement, and reduction. These concepts I'm going to talk about a bit later or in the next couple of slides. And then finally, we have to make sure that the correct animal model or the most appropriate animal model is being used for the biological question that we are asking. And the numbers that we are using for the study, they have to be statistically correct number. We don't want to overuse the animals, of course, but we don't want to underuse the animals, so that otherwise what would happen is the research will be statistically insignificant. So whatever animal lives have been sacrificed will be in complete vain. So there has to be a perfect balance between overuse and underuse of animals. And we have to make sure that whatever we do with the experimental design, the research that we are proposing has to be the highest possible quality. This criteria, when all of these criteria are satisfied, then and only then it is okay to do animal research. So as I promised, the 3 R's. The 3 R's, as I said, was replacement, refinement, and reduction. So there were very old definitions because these concepts have been around since 50s and 60s in the last century. What it basically means, replacement, is that we try to replace the use of animals by anything else. We can simulate in vitro experiments, or we can have computer models, or anything else basically that can replace the use of animals. But now they have expanded the definition to say that we also should try and accelerate the development of these kind of predictive models and other latest science and technologies to enable us and the other researchers to replace the animals where it was not to do so before. It was not possible to do so before. Next is refinement. Refinement is refining the technique and the experimental protocol, basically minimizing the pain, suffering, distress, and any kind of lasting harm that a research animal is going to experience. Now, again, they have expanded the definition to say that the advancing research animal welfare by exploiting the latest in vivo technologies and latest pharmaceutical advances and everything else, and also by using our understanding into the animals' emotional status and their sentience. We have to improve our understanding of the impact of the welfare on the scientific outcomes. Now, reduction, it's basically what it says. We have to reduce the animal number as much as possible, but also we have to remember that we don't want to underuse the animals. So that's basically sums up the 3 R's, which is the 3 basic pillars of any animal experimental planning. Now, interestingly, because you are mostly all in India, there is a 4th R that was added in 2004 by CPCSCA. It's called rehabilitation and reuse. So rehabilitation applies to the animals which were bred for the purpose of experimentation, and they were retained in any lab or animal houses for breeding houses for the purpose of experimentation. What they are trying to do is they try to, once their purpose is fulfilled and they are no longer useful for their intended purpose, they will ask us or the researchers to rehabilitate the animals into their into their natural habitat or the wilderness. And reuse is something that is actually a big point of debate internationally speaking, but in India it's not a point of debate. It's something that is an official guideline that if an animal can be used again in the same or different protocol, where another unused animals would have sufficed equally to meet the objectives. It should be done so. What it means is, if an animal can be taken again for an experiment, which is not going to affect the outcome of the experiment and also going to save another animals from being used in the same experiment, we should reuse an animal. That's what this guideline is saying. Now, I can, interestingly, in Australia, reuse is something that is very strictly regulated, and they are discouraging the reuse of an animal for whatever purposes. And reuse of an animal in Australia, at least, is only allowed under very specific, very strict circumstances, when it is not at all possible to not reuse an animal. The ethical guideline here is to the ethical boards, the ethical committees, they rather prefer for the researchers to euthanize the animals at the end of their intended tenure or the intended lifespan, rather than us reusing the animals. But you don't have to worry about that, because in India, reuse is officially recommended guideline. So after the 4th hour, let's move on to some really good planning and animal usage guidelines. So you don't really need to focus on the 2 photographs which are on the right and left side of the text. They are prepare and arrive guidelines. These are internationally recommended guidelines. Prepare stands for planning, research, and experimental procedures on animals. Recommendations for excellence. It essentially guides the entire formulation of the study. It encourages different dialogues between scientists and the animal facility. And it has very specific steps for quality control and the quality control for different components of the study in place. So if you follow the prepare guidelines, it literally helps you prepare a good ethical application and a good protocol for your animal work. And the ARRIVE guideline is the ARRIVE is again an acronym that stands for Animal Research Reporting in Vivo Experiments. So there was a Nature study published in early 2000s, which highlighted the fact that it was nearly impossible for most animal experiment scientists to perfectly replicate already published studies. Now, this is very shocking, because when a study is published, it should be easy to replicate it based on the amount of text and instruction that are already peer reviewed and published in a paper. But they found that more than 25% of the studies were impossible to replicate, and more than 50% of the published study at that time lacked very specific instructions and specific details, which prevented the other scientists to even copy the experiment, let alone replicate it completely. So that's where this ARRIVE guideline comes in. It basically outlines specifics for all different aspects of publication, which involves any kind of animal use. And the first edition of this had guidelines called Essential 10 guidelines. It was called Essential 10 because it had 10 different points, which were essential to be added in the animal experiment manuscript. But it was again updated in after 2011, and the recommended set, or the ARRIVE 2.0 guidelines, were published, and they had 11 different guidelines which were added on top of the Essential 10 guidelines. So all in all, there were total 21 instructions and essential guidelines that you could follow while writing up a publication, so that the experiment would be properly peer reviewed and it would be possible for other scientists to replicate the experiment. Now, the advantage of having a replicatable publication is that when there is good faith that it can be replicated, it essentially removes the need for the experiment to be replicated. What it means is, if you have used 100 mice and published a paper, and if you have followed the ARRIVE guidelines to the letter, all the following studies will be able to avoid using those 100 mice, and they will be able to build up on your already published data. This, in theory, should already be happening, but it was only possible after the ARRIVE guidelines came into place. So if you are going to think about having to do any animal experiments or something, I strongly recommend going through the prepare and ARRIVE guidelines. Now, there are some other critical considerations when you're using animals, because the animals have sentience. Sentience is the sense of self-awareness. So again, from the 1950s and 60s, the animal rights activists and different academicians, they have been debating this about the level of sentience and when it comes into play with regards to animal welfare when you're experimenting on animals. So this has already been agreed upon that animals have the capacity to experience pain and distress, and different procedures that would cause pain or distress to us, to people, they have to be assumed that they would cause similar levels of pain and distress in the animals. So first of all, the animal rights activists and academicians, they came together to give 5 freedoms that any sentient being should have. So they are the left column, the 5 freedoms. They are called freedom from hunger and thirst, freedom from discomfort, freedom from pain, injury, and disease, freedom to express normal behavior, and freedom from fear and distress. But then later on, a couple of more experienced academicians came together and gave us 5 domains of animal welfare. And then they correlated the 5 freedoms to the 5 domains. Essentially, what it means is that if we just focus on 5 domains as researchers, and we make sure that the animals have access to all 5 domains, we will be able to take care of all of their freedoms that we are supposed to. So what do we need to know about this? We need to make sure that our experimental animals have access to good nutrition. So the freedom from hunger and thirst can be already taken care of at that point. The animals should have access to comfortable environment so they can be free from discomfort. We have to make sure that we are maintaining their health and wellness so that they can be free from pain, injury, and disease. Now, this third point is a bit of has a bit of an asterisk associated with that, because when we work with animals, creating or replicating a disease process is a critical part of our experiment. So that's where the ethics committee also comes in. The role of the ethics committee also has to make sure that the pain, injury, and disease processes that we are inducing to the animals, they are in line with the science and the scientific advancements, and the potential benefits will outweigh any pain, injury, and disease that are being caused to the animals. Also, when we talk about pain, injury, and disease, it's again a very generalized form of talking, or generalized form of writing a guideline. But what we mean is that there should not be any undue pain, undue injury, and undue disease. So if your aim is to cause a Staphylococcus aureus infection in your animal and cause a skin ulcer with that infection, you have to make sure that the animal does not get any urinary tract infection or any other associated comorbidities or things like that. So there is a lot of other consideration that goes in the third point here. The next domain is the ability to express the normal behavior. So that means that we have to provide the animals with things that would simulate their natural habitats and normal behavior, that would allow them to express their normal behavior. For example, having hamster wheels or different walking wheels in the rodent cages. The bedding material that we use on those cages are also very specifically designed so that they can be comfortable and they can express their normal behavior, etc. And positive mental state. So at any time of handling the animals or experimenting with the animals, we have to consciously be aware of the fact that they are self-aware. They can see, they can feel, and they can understand different things. Maybe not as much as we do, but they do feel things the same way we do. So we have to make sure that their mental state is positive so that they can express their normal behaviors. They can be free from the different fear and distresses. That is also important so that our study outcomes will be not contaminated by these different confounding factors. So from a scientific point of view also, it is very critical that we take care of all the different 5 domains. So in summary, this is just a very brief summary of the ethical considerations that we have just gone through. Ethics and all animal welfare considerations must be met. The animal experiments must be warranted. A clear plan for maintaining the animal well-being is as important as a robust scientific experiment. And all in vitro results and inferences must be clearly and thoroughly corroborated before you can start an animal experiment. Now, we spoke a lot about, well, I spoke a lot about ethics and animals. So there is a very specific question that what is an animal? Because biologically speaking, any living creature that falls under the category of animal kingdom is considered an animal. But from an ethical point of view or from a legislative point of view, what really is an animal? So most countries, including India, defines animals as anything higher than an invertebrate in terms of level of sentience is considered as an animal for the regulatory purposes. So the hierarchy or the order of sentience goes from invertebrates to birds to rodents to canine and felines to bovine and equines. That means cows and horses. To primates, which is monkeys, and then highly evolved primates, which is a chimpanzee that they have capability to communicate and feel more complex emotions, almost as close to human beings. Now, a good question to think about at this point is that is fish considered an animal from an ethics point of view? So if you have an opinion about this, maybe you can all raise hands. So if you think that fish should be considered an animal, you can raise your hand and we can just count the votes based on that. So feel free to raise your hands. I'm going to hold for a few seconds here. Okay. Yes, votes are coming in. Okay. So far, 3 out of 122 participants are saying that fish should be considered an animal. Okay, one person withdrew their vote. That's okay, we can change our minds. Okay, so let's stop the voting now in next 3 seconds. If you have any opinion to give, please give right now. Okay, so that means majority of us thinks that fish should not be considered an animal from an ethics point of view. And majority of you would be wrong. Fish is considered an animal in India and in most other countries. Now, interestingly, fish also includes cartilaginous fishes like sharks and other higher evolved fishes, which is technically a mammal, such as whales and dolphins. So marine animals are also considered animals, and fish, including zebrafish or other clownfish and different other edible fishes are also considered animals when you're experimenting with them. So yes, fish is considered an animal, and you need to be aware of that. You cannot just start an experiment with fish without an approval from the ethics committee. Yes, wait 1 second. Yeah. Now I'm going to give you a brief overview of different popular animal models, and their common uses in research. The first two are Drosophila melanogaster and C. elegans, so fruit fly and roundworm. They are not they are invertebrates, and they are even below invertebrates. They are insects and nematode class of animal kingdom. So that means that they are not considered animals. And that means that a researcher can directly start an experiment if they are using these creatures. They don't need ethical clearance or an approval from the Animal Ethics Committee to experiment with these creatures. But if you move on to zebrafish, a mouse, rat, rabbit, guinea pig, or hamster, they are all considered animals. And other than fish, zebrafish in this list, they are all mammals, so very high level of animals as well. And you can see that they are used in very different, wide array of different applications and research, starting from genetic gene mapping, genetic studies, and different disease processing, to cell transplantation, device transplantation, vaccine, modeling human pregnancies, immunological phenomena, ocular research, bone-related research, joint-related research, chronic diseases such as diabetes, heart diseases, endocrinology, and oncological research. A wide variety of researches we are doing on animals. And I'm also going to list some important species and class, which is amphibian and reptiles. Mostly their use in research is evolution and ecological research. It's not primarily in medical research, but the development and regeneration based research is also very important, which can feed into the medical sciences wing of research. But why I have listed amphibian and reptiles in here is because they are very important in terms of training and education purposes. And that is why they're important in as medical research animal models from that point of view. And aves or birds. So we do aging, memory, parasitology, atherosclerosis, reproduction, and different infections, that based research in birds. And there are specific groups in the world, they specify in bird research as well. So all of the animals, all of the models that I've listed so far, except for the fruit fly and roundworm, they are all animals. And some cute photos of hamster, gerbil, guinea pig, etc. So all those 4 animals in the bottom, they are all rodent class of animals. Okay, now I found this really interesting stat because I think it was Dr. Anvesha who mentioned that mice are the most commonly used animal models. Just how commonly used animal models. So these are the animal experimental procedures statistics drawn from the Great Britain, only one country in the world, just over the 1 year, 2018. And mice were used over 1 million times in experimental procedures and over 2.5 million times in total experimental as well as non-experimental procedures. Then closely followed by fish, rats, birds, other mammalian models, reptiles, amphibians, primates, cats, dogs, and horses. So overall, 1.8 million animal procedures happened in Great Britain in 2018. They were just the experimental procedures, and overall 3.5 million total procedures happen in animal research. So this is just to give you an idea that the animals are very popular form of research. And this is what makes it very important that we all understand what are the ethical implications and what are the really important aspects of this animal research. So when we choose an animal model, because there is such a great variety of animal models to choose from, we have to consider different factors. Which would be these factors? Their appropriateness as an analog. So the biological question that you want to ask and you want to explore, we have to make sure that the animal model that we choose represents that biological system as closely as possible. Then transferability of information. So what it means is that if you see something very interesting happening in a tail of a mouse with a drug or with a treatment model, it's not really transferable to human beings because we don't have tails. It's just a crude example, but it's an example to give you a sense of what transferability of information means. Similarly, we have to look at the genetic uniformity of the different organisms when applicable. So if you're going to use more than one animal models in your research, you have to look at that, the genetic backgrounds of that. Also, the background knowledge of the different biological properties. So again, to give you an example, if you want to look at regenerative ability, and if you want to look at a treatment that potentially causes regeneration, using animals such as lizards or zebrafish is not going to be the best possible model because they have natural biological ability to regenerate their organs. Obviously, cost and availability is a very big concern because everyone works on a budget and nothing can happen without money and funding. So cost and availability are obviously a big concern. Then generalizability of the results. So this is one next step from the transferability of information. For example, if you get very good results by testing an anti-cancer drug, but if that is happening because of a specific biological phenomenon that happens only in that animal. It's not a generalizable result. To give you another example, let's say a zebrafish, you tested a anti-glioma drug on a zebrafish. The zebrafish have a very resilient nervous system, and they have a very good, very highly regenerative CNS, central nervous system. So that would eat up all the adverse effects of the drug, and you will of course get a very good promising result. So if you get a very good promising result of a drug on a zebrafish for treating a brain tumor or a meningioma, it's not a generalizable result. That's what it means. Next is ease of and adaptability to an experimental manipulation. So it should be easy to handle and manipulate the experimental procedure on the animal. It should be easy to handle the animal as well. Ecological consequences are, of course, of a very big concern, because if you're going to use a genetically modified organism, accidental release of that can have devastating ecological consequences. Also, if you're using an animal that is not native to the regional wildlife that you are living in, and an accidental release of that animal can also be very devastating. To give you a very nice example, was rabbits in Australia. Australia didn't have rabbits naturally, and when English moved here and colonized the country, they brought some rabbits here to hunt them, and they couldn't control them. So there was a huge plague of rabbits. They breed like rabbits. It's a phrase that is known to everyone, and they took over the whole country, and there was very bad droughts and damage to the crops and everything. So that's just a very striking example of ecological consequences of the work that you want to do. And ethical implications. For example, you may have seen some really interesting debate on COVID vaccine trials in the last couple of years. Because the virus was not, and the vaccine, the mRNA-based vaccines were not very easy and not very possible to test on animals thoroughly. The pharmaceutical companies proposed that we move on to human testing right away. And there was a good ethical consideration that how do you test for an effectiveness of a vaccine from preventing a disease, which would be, do you intentionally expose a human being to a potentially deadly disease? So things like that are very important to consider from an ethical point of view when you're working with animals as well. Now, I have a friend. His name is Dr. Pseudomycin. And I just want to see if people have been paying some attention to whatever I was droning on. And so these are just some really interesting case scenarios that we are going to discuss. And this is the truly interactive part. So I would really appreciate if people would interact now onwards more actively. So let's say Dr. Pseudomycin, he wants to do a preclinical vaccine trial, and he doesn't know where to begin. So he wants to make a vaccine on the avian flu virus. So what are the first things that you would ask or you would recommend to Dr. Pseudomycin? And this is where the interaction should start. I need input from the audience now. And I would request Dr. Anvesha to moderate the interactive session, please.
Yeah, sure. So everyone, who would like to answer the question, so it's not a question, basically you would like to express your thoughts. So
exactly,
please raise your hand. I will unmute a concerned person. Anyone would like to say anything about this point? I would appreciate if the students can try a little bit answer. Anyone, please volunteer yourself. So there is nothing like you will make the mistake. So it's a new thing basically for the students.
Yes, this is a discussion session. Yeah. You can also request information from me. So if you have more questions about what this is about, you can ask a question and I will give you the information. I can ask Dr. Pseudomycin, he's right here, and I can give you the information that from him.
anyone, please, whatever. So what you like to tell? What are you thinking? How should they start? Anyone, please raise your hand. You should try. I think you should try.
Okay, how about this? I start, and then maybe here in this case, or I have a couple more case scenarios, you will get a better idea of what you are supposed to be thinking about. Maybe that will help. So as I said, this is an avian flu virus vaccine that he wants to work with. Now, vaccine is still under preparation, so it's not fully ready yet. So is this a right time to consider the animal experiments? Of course, no, because the intervention itself is not ready. So let's not worry about the preclinical trial, but it will be necessary in the due course of time. So that's when we need to start thinking why, when, and what. So why? Why do we need to do this vaccine preclinical trial? Is it really necessary? It's of course very necessary because avian flu outbreaks can happen across the world and they can be potentially deadly to anyone who contracts them, or it can have very long-standing deficits after that. So why is easily answered. And when do we do that? So if you go back to the checklist that I went through in the end of the when section summary, we need to make sure that the vaccine has been thoroughly tested in vitro models. We need to know that it works in the in vitro models first. And we need to make sure that all the other ethical considerations are met. That's when we can start planning a clinical trial. We also need to refer to our arrive and prepare guidelines as well. And think about the 3 R's, because we are in India, 4 R's now. And finally, what? Now, here's where you can really help Dr. Pseudomycin out. What kind of model do you think we should use to see if an avian flu virus vaccine is working?
Can anyone remember for the virus, which model was there? Anyone? Just give it a try. Not only students, all the participants, they can participate. Is it mouse, rat? So someone is telling birds. Yes, they have typed.
So birds is a very good guess, but avian flu happens when the virus goes from birds to another mammalian system, which is humans. So it's a similar condition as the COVID situation. It went from bats to humans. So when the virus goes from birds to humans, that's when an avian flu outbreak occurs. So birds will be really a good guess, but no, unfortunately. Here's when you have to think about whether or not that virus can affect any other animal models. That's the real question that you have to ask. Does the virus affect any other animals naturally without crossing the species barrier? Because that would be the ecological considerations that we just spoke about. If we unintentionally make the virus cross the species barrier, that can be really catastrophic just for the sake of research. So what animal model can we use? It depends. Whichever model can contract the virus naturally. If no other animals can do that, then we have to go to clinical trials like we did with the COVID vaccine. In that case, the preclinical trial will be useless. And what are the ethical considerations? Well, basically, whatever we just spoke about, they are all ethical considerations. Okay, so now I hope you have had some ideas. So because we don't have a lot of time left, I think we should go quickly to the next case.
Yeah, sure. No issue. UK can take.
There you go. Now, Dr. Pseudomycin had a very good vaccine trial, so he was promoted, and now he has made a new bone implant. And he believes that we can use this bone implant to heal complicated fractures, or when we have to resect out bone tumors, we can use this implant to heal very unnatural gaps in the bones. And he now wants to test it on an animal model. So let's start with why, when, and what. do you think the question why is well justified? Is it important to test this bone implant, or is it okay to just go to humans and just put this in people?
So anyone with a view, should we go to the animal or some other species, or should we go directly to the human? So what do you feel? Can
So
type
it's,
your answer.
yeah, it's a yes or no question only. Do you think
Just
an
you
animal
have
trial
to
is
tick.
required?
So will it be preclinical or the clinical one? Yes. So Shumon is telling yes, and another one
Yes.
is also raised the hand.
Yes.
Yes.
Yes, so that would be correct.
Lot of
We need
yes.
to- Yes, good, very good. Finally, some response. That's great.
Yeah.
It's nighttime for me, guys, not you. It's the middle of the day for you. You should be awake. Okay, so we definitely need to do an animal trial. You are absolutely right there. And the why question is, of course, very well justified. Now, when can we do that? Do you think we should do some detailed in vitro work to test a bone implant, or is it okay to just see if the implant works in the animal models? When can we do that? Is there any other ethical considerations we need to be worried about?
Anyone? Do you have any idea? What do you feel? Should you go for the in vitro one, then to the animal, or directly to the animal? What do you feel? So I guess if you can elaborate a little bit about the in vitro one, so then
Right.
yeah,
So do you think we should
just
see?
briefly.
Yes, of course. Do you think we should see if the material that we use for bone implant doesn't cause any cytotoxicity, or doesn't just flat out kill the cells before we put it in, whether or not it dissolves in blood and travels to the rest of the body? There are things like this. We should. Do you think we should test this, or is it okay to directly just put it in the animals?
Yeah, so some students have there given the answers. So first in vivo, in vitro, and then to the animal.
Right. Perfect. So of course, we need to do a detailed in vitro characterization, specifically anything that goes in the body and stays in the body, not just a drug that can go and metabolize and get excreted. For any implants or devices or any transplantation-based therapies, we must know what exactly it's going to do once it goes in the body. And then finally, what kind of animals do you think we can use for this? Do we go to directly pigs, sheep, or horses, or should we go for smaller animals like mice and rats and rabbits?
Little animals, somebody is saying. Yeah.
The little animals, mice and rats. Okay, so little animals, yes. But typically for bone transplantation, bone implant surgeries, we don't really prefer mice much because they're really tiny. And their average weight is between 20 and 30 grams, which is nothing. So that's why we usually at least prefer rats and ideally rabbits if we can. So just something to remember, but in theory, in principle, you are right. We need to start with the smaller animals. And because of their faster and much rapid life cycle, we can get the long-term effects tested very soon. And that's when we can move on to larger animals if needed. And what about the animal well-being? Do you think there are any serious considerations for animal well-being? So again, because we want to put a bone implant, we are going to break their bones. We are going to cause deliberate injury. So pain after the injury and then after the transplantation of this bone implant, everything will be a big consideration. So we need to think about the animal well-being as well. And we need to be very actively aggressive about treating any kind of pain-related effects on the animal well-being. All right. And last one. Now, Dr. Pseudomycin, he needs your help with one final project, and he has developed a stem cell therapy for regenerating nerves. I put it in because this is basically what I do. So he has done a lot of in vitro experiments and he has seen very promising results. Now he wants to go to a clinical trial, just like me. So do you think me and Dr. Pseudomycin, we should do a preclinical trial with animals? I mean, this is a given yes, of course, right? We cannot directly go to human beings from a petri dish. So yes. So again, why is answered. We already answered that we in the previous two cases. But is this a good time to start preclinical testing? See that the therapy has been tested in vitro and we have seen some promising outcomes. So do you think this is a good time or do we still need to do more before we do preclinical trials? Now or later, two options.
What do you think? So now someone is saying now, and a lot of nows.
Yes. Yes. And you would be exactly right. Because we have done our due diligence in this case, it's okay to proceed to a preclinical trial. And what animals should be used? So do you think a lizard or a crocodile or a zebrafish is a good model, or should we use rats or rabbits or monkeys?
Which animal do you prefer in this case? Someone is saying rabbits, someone is saying monkey. Anyone else? Come up with the names, what you can remember at least. What do you like? Rabbits and monkey. Some more answers?
Lizards.
Someone is saying lizards. Another rabbit.
Okay. So the answer would be lizards is not an appropriate model because they can regenerate their limbs. Of course, we are talking about the nerves, but the limbs and tail also has nerves. So they do have more than above average capacity for nerve regeneration. So we don't want to use that model. Mice, rats, and rabbits would be the first go-to. And based on how well we do with those lower mammalian models, monkeys would be next step, or maybe one step after the next step. Maybe we can go to feline or equine model first, and then we go to primates. Monkeys is a very high mammalian model, so that would be the natural course of progression in this case. So that essentially concludes everything that I had prepared in this presentation. So if you have any questions,
I was just about to say so. If anybody has any question in addition to that, you can feel free to ask anyone, please. If you can raise your hand, I can unmute you. Or you can type your question as well. Any question from the students, faculty members? So already we have our second speaker with us, Dr. Ashish Bala. So in the meantime, I would like to once again ask all the participants to share any question. Hope we have enjoyed a lot in the last 3 slides. Actually, it was pretty interactive and I also learned a lot from this.
That's nice.
Yeah, that was very interesting and very engaging, I'd say.
Okay, so maybe I did a very good job of explaining everything and no one has any questions. Or maybe I was too boring and everyone fell asleep. One of the two things have happened. But anyway.
I didn't find it boring, but students, they have found it interesting. I say
yes,
so.
yes. I'm just I'm just joking a little bit. But just one final thing here. If anyone has any questions from this, please feel free to forward your questions to me or to Dr. Anvesha, and you can forward those questions to me in return. So, and I also have shared the presentation with Dr. Anvesha. So if you have any specific request for information, also I think if ma'am agrees.
Yeah, sure.
You can request specific information from ma'am as well. Okay.
So
It was
I
really
will
nice
share.
meeting you, everyone. Yes,
I will share your email ID and presentation with the participants. I will do that.
perfect. Yes. Okay, very nice meeting everyone. I will sign off now. Good night.
Yes, before that, I would like to present a certificate for
Oh,
as
thank you.
a token of gratitude. Just let me share that.
Yes.
Yeah. So I hope it's visible.
Ah, yes, it's
And
visible.
yeah, it's visible. So it's from all of us, from on behalf of the Department of Pharmaceutical Technology, School of Medical Sciences at Adams University. It's our pleasure to share this one, and thank you once again for this engaging talk.
Thank you for having
you.
me. Thank you for inviting me.
Thank you. Thank you so
Okay.
much.
Good night.
And good night to you. So now it's the time. Now it's a just a minute. Now it is the time to move forward with our e-workshop. So already our second speaker, Dr. Ashish Bala, is with us. He has already joined. So I would like to over this session for the moderation to Dr. Shushmita Patra. So she is a colleague of mine. So she would be moderating this session. So what to you, ma'am?
Okay, thank you, Dr. Anisha ma'am. Once again, very good afternoon to all the dignitaries, faculty, and all the students present over here. I, Dr. Shushmita Patra, Assistant Professor of Department of Pharmaceutical Technology, School of Medical Sciences at Adams University. And I hope everybody has been enlightened by the very enriched talk delivered by Dr. Ronak Reshamwala. And it is my pleasure to welcome our second speaker, Dr. Ashish Bala, an associate professor in the Department of Pharmacology and Toxicology, Guru Nanak Institute of Pharmaceutical Science and Technology. And also he is an associate editorial board member of Endocrine, Metabolic and Autoimmune Disorders Drug Target, an official journal of Association of Medical Endocrinologists, Italy. And his major research interests are cancer immunopharmacology, endocrine, metabolic, and autoimmune diseases, free radical biology, and cellular inflammation, toxicological studies, and he has done his significant contribution in these research areas. In addition, he received various awards for his outstanding contribution as a reviewer in several reputed journals, and he is selected and qualified as CPCC, Ministry of Environment, Forest and Climate Changes, Government of India, as a nominee of Institutional Animal Ethical Committee on 2018 onwards. So within a short time, I cannot complete his whole achievement throughout the career, but without any delay, I just want request to Dr. Ashish Bala. He will speak about the basic concepts of animal handling and ethics in animal experimental pharmacology. It gives us great pleasure to have you with us. And as we have been eagerly waiting to hear from you, sir, now I am sharing the stage. Over to you, sir.
Okay, thank you, Sushmita. Let me share the slide.
Sir, can you a little bit increase
okay
the
now,
volume? Sir, a little bit louder, please.
Okay. Is it okay now?
Yes, yes, sir. Yes, sir. Now it is okay.
Let me share my screen first.
Yes.
I think it is visible to everyone.
Yes, sir. It is visible. Yes.
Let me make it full screen. Okay, is it visible in full screen mode?
Yes, yes, sir. Yes, sir. It is visible.
Okay. Thank you, Sushmita, for my introduction.
Sir, I think your voice is coming very low.
I will be...
Uh,
Is it okay now? Not?
No, sir.
Now it is okay?
Yes, sir. Now it is okay.
It is okay now for everyone?
Everyone, it is okay? The participants, can you hear?
Yeah, is it okay? You can write in chat box also.
Yes, sir.
Otherwise, I have to,
Yes,
I
sir.
have to,
Yes,
I
sir.
have to arrange something else.
Yes, sir. They are responding. Yes. You
Okay,
can continue, sir. Yes.
Yeah, okay. So I will be discussing on the basic concept of animal handling and ethics in experimental pharmacology. So as because it is a e-workshop, so I thought that I have given my best to give number of schematic representation with figures and number of videos is given. So make the student understand the basics of animal handling as well as what are the ethics in experimental pharmacology that is applicable to us. But before I start to my content, I want to thank and congratulate the organizers, especially in Adamas University, because they have thought to organize this type of e-workshops. Because what I understand that the government of India rules and regulations, especially on animal research, they also encourages this type of workshop because this type of workshops will give an additional value in the courses of UG and PG, because maybe somehow they are unable to handle number of animal simulation experiments. So for that, I want to thank them that they have thought of it to arrange this type of workshop. And I also want to congratulate them because the participant is very significant also. So before I start, I thought that I will be giving a common viewpoint of the animal research. That what are the common viewpoint for a layman or for a common man? Okay. So they thought that when medicines and other treatments for humans is created by the scientists and doctors maybe, so animal experiment is tested upon in that time only.
Sir, sorry for the interruption. I think the participants are not getting your voice properly. So better you disconnect the speaker and directly connect. Yes, that will be.
Is it okay now, Sushmita?
Yes, sir. Yes, sir. Better, sir. Yes.
Is it better now?
Yes, sir. Better. Far better.
Okay.
Yes.
Okay, so what I thought that at the beginning, I will be giving some of the viewpoints of like for different person in the society, like layman. So what they thought about the animal research. So actually, they thought that when the medicines and other treatments of humans is created by the scientists or doctors, so that time the animal is used for the test. Okay. So then next is what are the scientists' viewpoint for the animal research. They thought that study of animals when there is no alternatives and it is impractical or unethical to study human directly. So that time, that means, so just to initiate the clinical trial, we have to confirm it in the animal models, and that's why the scientists have used the animal models. So this is the scientist point of view. Advocate point of view. So as know that advocates, what they can thought about the rules and regulations. It is important that they will be thinking about the ethics committee rules and regulations, because they will thought like that way. What are the rules? What are the regulations and all? Next is, what are the governmental point of view? Government also knows that experiment on animals are very strength of modern medical science and scientific research. But what is important that the government will be thinking at cost, risks and benefit ratio. So is it what are the outcome? What are the cost I am spending for the animal research? Because governmental point of view will be like that. Okay. So next is, what are the animal activists or some of the social workers' point of view of animal research? So they will be thinking that mice and medicines, what are the right for them? What are the right for humans and what are the right for mice? And they will be also a strong supporter of animal welfare. And that's why they will obviously proposing some of the alternative methods if it is applicable. And I think all the UG and PG students knows that alternatively we are using number of simulation experiment and all, because of number of government regulations and everything. So that's why this is a common perspective, that what are the common viewpoint of animal research in our society. But actually, what is animal research? So I think the last speaker also told very perfectly. I have seen very 2-3 slides at the last, and his topic was very interesting also. Why, when and how and what. So what is the pharmacological point of view? The animals are biologically similar to humans, first of all. Second is, the animal are susceptible to many of same health problems like cancer, diabetes, heart disease, and etc. So that's why we can manipulate some of the disease model in the animals. So that's why we can test some of the molecules in the animal models. And obviously, with a shorter life cycle than humans, the animals model can be studied throughout their whole lifespan and across the several generations. So these three is the most important point for which the animals are used for the experimental pharmacology. Okay, so the uses of animals in some form of biomedical research remain essential to the discovery, not only for the cause, but also for diagnosis and treatment of disease, not only for human, but also for animals. And this is a very simple placard that I got it from the CPCSEA training. It's very important and very interesting and significant, what I believe just from my heart, that the animals are telling that we don't smoke, we don't drive, we don't and wear makeup and perfume, we don't use paint, we don't drink alcohol, we don't drop bombs. Now everyone is knowing what are the importance of bombs and what is going on in the world. So they don't even drop the bombs. We don't take drugs. Drug means here it is not the medicines. It is some of the narcotics and all. Just because of humans do it, why should we suffer through the experimentation? So I think this is the message that is issued by CPCSEA only because of public interest. That this is telling that how much ethical consideration I have to think before I start the animal experimentation. Okay, so this is giving an important message to us. Okay, so I thought I will be discussing what are the different stages of animal research in the drug discovery process. And for that, I started with the three phases of drug discovery. One is the target selection and validations. Second one is the discovery phase, discovery in terms of efficacy study, the optimize the lead and lead optimizations and validations. And third one is the development phase. So development phase means it is especially for the toxicological studies, as well as the clinical trial and post-marketing surveillance. So nowadays, the companies worldwide, not only in India, but also in the other some countries also, they started the discovery process with the disease, or we can say the target-centric approach. So what is the meaning of target-centric approach? That means the companies or the funding agencies, they specify the target first, that at what particular disease I will be inventing my molecules. Not like it is, because earlier it was in a compound-centric way. What is the meaning of compound-centric way? That means I am having maybe 20 or 50 number of NSAIDs in the market. So I will identify that what are the similarities in that particular molecules or particular drugs available in the market. So based on that similarities, I will make my own molecules. Then I will do some of the animal experimentation. So this is the compound-centric approach of drug discovery. But somehow it is not well accepted by the scientists. But nowadays, the funding agencies and the companies, they prefer target-centric approach. Target-centric approach means they will do the studies on disease mechanism first. Disease mechanism means what are the pathophysiology of the disease, what are the etiology of the disease, what are the biological targets. So how I can manage that particular disease. And based on that they will also be doing on the molecular studies of that particular targets through QSAR, the quantitative structure activity relationship, as well as high throughput screening for specifically for the candidate search. And once the initial candidate is found, they will be testing the same thing on animal models to see the initial efficacy of that particular candidates. And once the initial efficacy is done on a specific species of animal, especially on inbreed animals, transgenic animals, to see the activity in terms of agonist or antagonist, or maybe it's a enzyme activator, or maybe it's an enzyme inhibitor, in what angle they will do it. But in the next, what is important that I need to specify my target, that my molecule is working in that particular targets. So I need to identify the receptor or ion channels or the transporter, or maybe some of the enzymes, or what are the specific signaling molecules that is either inhibited or activated by my candidate. So that has to be identified. And next is, now I am having a initial assumption on my molecule that it is giving some effect. But I need to go for lead search. Is it ultimately working in the particular disease mechanisms? If that animal model is ultimately similar with the human models, so that is a question mark. And for that, I need to develop a specific assay. So that will be highly equivalent to the human disease mechanisms. And I need to also study for the chemical diversity. So that is the meaning of lead search. And the next is the lead optimizations. So the lead optimization means the specific selectivity of the molecules with a specific target only. And once the lead is optimized, lead is searched, lead is optimized, it is very important that I have to see the safety of the molecules. Lead safety molecules. That means I have to thought about the toxicological part of the molecules. See, one thing is interesting in animal research. In the animal models, the efficacy is studied first and toxicology is studied in the second. But what happened in the clinical trial? The clinical trial is studied with phase 1. So phase 1 is conducted in the human volunteer, healthy human volunteers. So that means the safety will be concerning first and the efficacy will be in phase 2 and phase 3. Okay, so we know that phase 2 is only with a limited number of patients with a homogeneous populations in a single center study. But in phase 3, it is a heterogeneous population, more number of participants will be there. And even though if it is successful in phase 1, phase 2 and phase 3, it will go for phase 4 as well as the approval process, and it will come to the markets. So what important in this slide is that initially in the animal models, the efficacy will be studied first. Then before starting the clinical trial, the toxicological part has to be studied. So this is very important. So this is the reference, complete reference as per the Government of India guidelines. This is compendium of CPCSEA. So where they have mentioned the animal care, the benefits and ethics of animal research, the protocols and everything, they have given the guidelines in form of guidelines. So all the protocols, all the rules and regulation is mentioned in this compendium. So I've given that much of reference for that, reference purpose only. But what is my personal point of view is that we have to understand that what is the recent trends of animal research. I'll be showing one slide that what is the success rate of animal research. That means if I get an effect in animal, ultimately is it coming in the same effect in human? So that indicates the success rate. So I will be showing that what are the success rate and why it is important to understand the trends of animal research all over the world, not only in India. So what is going on outside? What is the more scientific models of the disease and all? I will be showing some of the videos also on that. This is very conventional way of imaging an animal house. So I have given this image that was having with me from my BPharm time, that everybody is having a thought that animal house is just like that. It's having a plastic cage, plastic bottles, having a metal rod, and it will be kept like that. But is it actually that? What's the world is demanding? And what is the specific ethical consideration that is coming in our mind? I'm not telling that if the animal is maintaining like that way, the ethics is not maintaining. I'm not telling that. But the question is that the first point that will come to a pharmacologist is all the cases are in equivalent environment. That will come to the first questions. Because the cages that are in the first rack, they're not in the same environment in the third or fourth or last rack. So automatically, if the animals are not kept in an equivalent environment, the data will be invalid. So that means I'm telling, maybe I'm ethically correct, but maybe I'm scientifically wrong. That means my work is useless. So that's why what we need to understand, that what CPCSEA is also telling every time, that we have to be ethically restricted, ethically strict, but not compromising the scientific quality. So that means you have to understand at what level I will maintain the ethical guidelines and all, and at what scientific outcome I will concern. That is also important. I will be showing that what are the advanced animal houses is looking like that. This is an animal house. It is obviously, you can say it is an IVC cages, individually ventilated cages, IVC, as you can see. So what is the specialty of this system or devices? As you can see, this device is having an air handling unit. That means that air handling unit will filter the air with number of HEPA filtration process and all. They will purify it. They will maintain the temperature of the air. They will maintain the sterility of the air. They will maintain the humidity of the air. And they will send it to each and every cages, because each and every cage is having a air in and out channel. Just as you can see it here on the top, that air in and out channel is also present in the rack, and the same knob is also present in the cage. And here the cage is specially designed. What is the specialty in this case? So there is no provision to come air from outside to inside. But what is important here, that is a safety valve. As you can say, this is known as the breathing window. Sometimes maybe somehow there is a power cut, maybe something malfunction in the machines, animal will die. So for that, what they did in the cages of the animals, they given a breathing window, but that breathing window is having a HEPA filter, so that every time the air that is coming from outside to inside is also sterile. What is important in this system, that all the animals or all the cages are in equivalent environment. I hope so that everybody is understanding that the air is coming from the same system, the air is going out from the same systems. So each and every cages presenting here in the IVC rack, or we can say individually ventilated cages rack, is having a same environment. So the chances of individual variations will be less. Okay, I will be showing some of the videos also with the same system, that how this IVC system is working. And number of academic institute in West Bengal, as well as number of CROs, is having these IVC systems. I'm not telling that all the academic institute is having, but number of academic institution is having, and number of CROs, because for CRO it is a compulsory. Otherwise, they will not get the GLP as well as ALAC approvals. Okay. If it is a question of breeding, I have to be more conscious about ethics. Going about in details about the breeding purpose and all, because if it is a breeding purpose, the ethics committee rules and regulation is completely different. They are very strict, because I am concerning about the breeding of animals. I'm not going in details, but I wanted to show these nice pictures, how they are actually maintaining in the animal house for the breeding purpose. And this is a very, very simple animal house having a IVC systems. And as you can see, the IVC system is having a wheel on its rack. So if you need to move it, you can easily move the entire system. It's not like that individual case has to be moved. The entire IVC system can be moved from one room to another room, and that can be handled easily. And there is no question of the outside environment at all, because outside air is not going inside. Everything is controlled by the air handling only. That is important. This is the fact. I got it from some of the British medical journals, some of the reputed journal in medical science, and they are telling, you can see in the statement, more than 90% of the animal experiment failed to lead to treatment to humans. More than 90%. That means success rate is 10%. The question is why? Question is why is very important. If I am ethically correct, but ultimately I have to understand that my outcome, what is my outcome? Is it, if I am ethically correct, but is it my outcome is giving a scientific concern? No. Then what is the importance of ethically correct? Okay. So this journal is very good journals in medical science, and they are telling, it is a report in 2014. So the question is why? The question is why and how? The first questions comes to the pharmacologist is that concerning to the individual animal variations. Individual animal variations in terms of strain, in terms of maintenance, in terms of handling, in terms of feeding. I will be showing some graph also given as per WHO, that how fit or how the animal care is giving variations in the biological parameters of some of the parameters. I will be showing that particular graph also. So that indicates that how much is important to have an ethical handling of animals, ethical care of animals, along with the ethics rules and regulations. This is the, as I told that I will be showing the IVC system completely, how it is working. And I got it from the Orchid Scientific Company. green is the inlet and red is the outlet. This is the cage. This is the design of the compact cage system. Okay, so I think everybody enjoyed the systems, because what is important in this system is that first time I have seen this in my postdoctoral research, but now it is very commonly available in West Bengal also, and obviously in India also. Not that much of costly. It's very simple and very convenient cost also in that instrument. Okay, so this is something I got very interesting to show to all the students and obviously all the participants, that this is the guidelines given by WHO for QPBR, Quality Practice of Biomedical Research, and see how the food consumption is giving a variations in respect to the animal care. If the animal is kept entirely in wire mesh, food consumption is very high, and if the animal is just maintaining in a plastic cage without any litter materials, that means without any bed on the cage, it's in the average food consumptions. And if the animals is in plastic cage without the litter materials, or just with the litter materials, the food consumption is very less. That means it indicates that how animal care is important to give an ultimate scientific outcomes. Because if the animal's food consumption is not appropriate, if it is not uniform to all, it will give a variations in the ultimate data. Second, as I thought, I will be showing the second graph, what given by WHO as per QPBR guidelines. The PBR is easily accessible in the WHO website. If someone is interested to see it, details guideline is there, that what are the quality practice in animal research for maintaining in the biomedical scientist. See, influence of variables in the CPK value, the creatinine phosphokinase value, depending on the anesthesia they are using in animals. If it is carbon dioxide, even though not only because of anesthetic agents, but also at what route you are just collecting the plasma or blood, that is also important. And see how much variations are there: 100, 125, 86, 89. It's not like 100 and 101, not like that difference of the value. That means the collection process, handling, the specific process of anesthesia, the specific process of euthanasia, how you are using, that is ultimately affecting your ultimate data. And that has to be in the consideration in the study. That means how much concern is required to make the animal model or animal study reproducible is very important. And what the WHO told is very clear, that they told if there is a sound science in the methods, not accepted. If there is a sound science, as well as we can say if it is only in the quality practice or quality ethics, then also not acceptable. But if it is both, That means if your models or if your experimental design is ethically and quality practiced method are maintained, along with it having a sound science, then only it will be accepted by the worldwide community. Otherwise, it will not be accepted. It's very important. So once my topic is on animal handling, the e-workshop on animal handling. So one thing I believe personally, that in pharmacology, there are two major challenges to the animal model development. One is to induce the disease in animals, and second, to collect the biological samples from the animals. This is very, very important and very challenging to a pharmacologist. Because being a pharmacologist, what I believe personally, that these two is very challenging. And in these two only, I have number of ethical concerns as well as number of what I can say experimental skill setup that is required to make the data reproducible and to get an ultimate scientific outcome. The needle is basically is determined by the needle gauge number, and as I have mentioned, the lower the gauge number, the wider the diameter of the needle. This is very important for everyone to understand. So lower the gauge number, diameter will be more in the particular gauge number needles. So the gauge number is important at what particular route you are giving injections. Maybe it's interperitoneal, maybe it's a subcutaneous, maybe it's intramuscular. The gauge number is important in that angle. Not only for that, it's important from animal to animals. If I am handling animals, I am giving a subcutaneous injection in mice, maybe the gauge number will be different. But I am giving a subcutaneous injection in rat or rabbit, maybe I will take a separate gauge number of particular syringe and needles. But again, I am telling that it depends on personal skill setup. Sometimes maybe someone is comfortable in 26 gauge number for giving a subcutaneous injection, but maybe someone is very comfortable in 20 gauge number. He is having a specialized skills on that, because in industry, the skill is very important. And next is the needle's length. Needle length is also important because length is determining that at what route you are giving injection. If it is a tail vein injection, I will not take that much of length of the specific needles. I will take a very small length. But if I need to give intermuscular route, I have to take a very higher length, 1 to 1.5 inch of length. Next is the syringe size, not the needle, syringe size. Syringe size is important when I need to inject as per the quantity of the volume of the particular drugs. If my volume is very less, I need to inject very less quantity of volume, I can take a very small syringe size. But if I need to inject more in volume, I can take the separate syringe size, but I can maintain the same needle size also. Okay, so this is very important to understand. So in experimental pharmacology, it's first important to understand that in my experiment or in my task, at what type of needle I will select. It's very important, because what I believe personally, whenever I start animal experimenting, I thought like that way. What type of gauge number I will take, at what type of length I will do, at what type of syringe size I will take. That is important, because in that only I can control my animal suffering one by one way. This is a very good reference. I got it from Becton and Dixon company, that at what gauge number it is available in the markets. So what I prefer personally, it is 26 gauge. As you can see, 26 and 28, it is applicable for all common route. So 26 to see, as you see at the color, the pink color is for intradermal injections, intermuscular is light green color, and the light yellow color is for subcutaneous injection. And the common is 26 and 27. So you can use, because again, I am telling that it depends on your personal skills. Maybe I am comfortable by giving an intermuscular injection at gauge number 18. I am comfortable. But conventionally, the common way, that 26 and 27 is very conventionally used, and it is used for all the routes of administrations. So similarly, in needle length also it is important. So I put thought that what route I am giving injections. What is the purpose of using a needle? Needle can be used for two purposes. One is to give some medications to the animal's body, or sometimes to collect the blood from the animals. In both ways it is possible. So in that angle, I have to thought about it, that if I am injecting something, if I am injecting some of the inducing agents, or maybe some of the medications, or some of the test compound, so at what needle size I will take, at what gauge number I will take, at what syringe size I will take. That is important. Otherwise, you are not thinking about the animal suffering and all. I will be showing some of the equations of animal suffering also in the last few slides also. So first, I showed what are the techniques that is very important to understand for intravenous injections. As you can see here, the intravenous administration of any test item. It is not like that every time we are injecting the test item, but sometimes we are injecting the inducing agent also. For example, I need to make the animal diabetes. I need to give a intraperitoneal injection of STZ. Okay, so maybe I need to make a skin cancer. So maybe I am giving a chemical carcinogens to the subcutaneous injection. So it is not always true that every time I am injecting the test drug to the animals. Maybe I need to inject some of the inducing agent also. That is important. And what is important, just as because you are giving an intravenous injection, it is so much painful. So sometimes the restainer is used. Restainer is very simple, although the term is very difficult, but it's very simple animal holder, so that the animals will be comfortably fitted there. I can just take the tail or maybe the biological part out, so that I can give a very simple intravenous injection. The preferable gauze size for intravenous injection is 26 as per my concept. But again, I am telling it's vary from person to person. Okay, so 26 is perfect for rat and mice. But if it is for rabbit, I will be considering to giving the intravenous injection in the air vein. It's very easy to give in rabbit. So that's what I'm telling. At what animals you are taking, at what route you are injecting, and at what volume. Depending on that, you have to select the needles. That is important. Next is subcutaneous injections. So the subcutaneous injection is very common, and number of times we have used in our experiment also. So it is preferable that it is given behind the neck and shoulder blades. So what is the process? It's very simple. Just drape some of the skin so that you make a tent. This tent is very important, and it has to be given inside the tent. The standard size of needles recommended for giving a subcutaneous injection for mice and rat, it is 20 to 26 gauge, and needle size vary from 0.5 to 1 inch. Again, I am telling it's vary from person to person. I have given as per the standard procedures, but again, I have seen number of pharmacologists. They are very comfortable by avoiding these rules and regulations. They're very comfortable with some other ways because they have highly qualified skills. As you can see, it's very easy to give subcutaneous injections. So sometimes the animal don't need to anesthetize for giving a subcutaneous injection because it is very easy and convenient. Only you make a tent, inject it accordingly as per the volume required, and the preferable size of the gauze is 20 to 26, depending on animals, obviously. Interperitoneals, as because the interperitoneal cavity is very huge, so the absorption rate is very high. So sometimes the experimental pharmacologists thought to administer the test drug in the interperitoneal cavity because absorption will be very high. And it is also given very easy that the interperitoneal injections are typically made in lower right or left quadrant, not in the midline. Very important. Not in the midline. Lower right or left quadrant. Why? The chances of infecting the internal organs will be less. What the points? And the preferable size of gauze is 26 to 28 gauge, and the length is 0.5 inch, because here I don't need that much of length, 1 inch or 1.5 inch, because I have to give an interperitoneal injection. Okay, so what is happening in some of the labs that maybe it is not available, the gauze number is not available. I am giving interperitoneal injection, but my size is 1.5 inch. So what is that? Means you are doing an unethical practice, because the possibilities of animal suffering or infecting the internal organs will be more in that case. So that is very important to understand. Intermuscular, very simple. So for sometimes intermuscular is also given using a restainer, some of the animal holders, so that I can access the thigh muscle. I can push it in the thigh muscles. And the intermuscular injections is to be given in deep into the muscles. Use the needles long enough to penetrate the skin, long enough. I need maximum size of needles here because I have to give intermuscular injections. And the subcutaneous tissue and fat to reach the muscles is important. The needle should be entered the skins perpendicular to the skin surface, very important. Muscles not in the subcutaneous route. So my objective is to give intermuscular injection, not subcutaneous route. The preferable size of gauze number is 24 to 28, and here the size is more, 1 to 1.5 inch, not like interperitoneal injection, because I need to cross the needle through the fat layer and through the subcutaneous layer. So that's why the selection of gauze number and needle size is very important for giving an intermuscular injection. Because ultimately what is happening, if it is not properly given, maybe that is ultimately affecting in your study outcome data. This is the most convenient on the oral feeding needles. Everyone knows, and it's very common that sometimes, because in pharmaceutical industry, they prefer the drug to be active in oral route, because this is having the highly patient's acceptance. And if it is not active in oral route, the formulation scientist will make it orally active. So in pharmacology also, sometimes we are forced that why not in oral route? You can give the medications in oral route. So for that, we have to use some of the oral feeding needles, as I have given. It is available in different gauge number, starting from 18 to 8. Here also same thing. Less the gauge number, more the diameter of the needles. It's very important. So the length is very important. At what animals you are giving the oral injections or oral feeding. If it is a small size rat, and if it is a healthy adult rat more than 300 gram weight, in both cases, the gauge number and length of the specific needles will not be same. What is happening? Maybe if your animal size is high, but you are giving a very small size of the needles, so ultimately it's not going to the stomach. So what is happening? Animals will vomit that particular test item. So how is affecting? So your data is affecting in your data. Ultimately, why the problems will come? Because animals will having a tendency to vomit it if it is not properly going to the stomachs. So the selection of gauge number and length of the needle is very important to giving an oral feeding to the animals, especially in rat and mice. It's very important. I've given some of the videos. I got it from some of the references that how I've given IP and oral, how it is given actually. This is just for reference. As because it is a e-workshop, I thought I'll be giving number of videos to make the students understand and make the participant understand. This is for the oral feeding. Very simple and convenient, but you have to thought about, as I feel personally, I have to start thinking of needle size, needle length, syringe size, syringe length, what route I am giving, at what volume I need to inject, at what type of animal I am using. That is very important. It's not like that I came to animal house, whatever it is available I am giving, not like that. Because you have to understand the scientific outcome. You have to understand about the reproducibility of the data. That is also important. And you are not thinking about the animal suffering. You don't have that appropriate number of syringe and needles, and you are forcefully injecting to the animals, and ultimately animal is suffering. So it is unethical practices for the animal house. So next is whatever till now I told, it is the giving of injections or handling of needle and syringe by giving an injection to the animals. Maybe it's a test item, or maybe it's an inducing agent for the disease, whatever it is. And I don't care for that, but the technique you have to understand. If it is a test item or if it is a inducing agent for particular disease, it doesn't matter, but my skill for injection has to be very perfect. Next is, as I told, the challenging to the pharmacologist is the collection of blood. It's very important, collection of biological sample, not only blood. Some of my students in M.Pharm, they are isolating the pineal gland. So it is very important to identify that what is the pineal gland present in the rat brain. It's very challenging. So similarly, the blood collection is also very challenging, because sometimes I need huge quantity of blood, maybe 5 ml. I'm getting 1 ml. So how I will manage that? That means I need a specialized skill to collect the blood from the animal, so that I can do all the possible molecular studies to give a valid conclusion on the molecular mechanism of my molecules. That is important. So the maximum biological sample collection is very important. So whatever I am showing now is the process of collecting blood from the animals. And this is, I got it from a Nature publications, is very recently in 2015, I got it. What they are telling, when collecting a small volume of blood, retroorbital bleeding with a thick capillary and without anesthesia causes the less stress in mice. Whereas jugular vein bleeding and facial vein bleeding causes the most stress, and saphenous vein bleeding causes the most lasting damage in mice. So what is important in this outcome, in this paper? That I have to understand at what method I am collecting the blood. I have showed the WHO guidelines also. They told the collection of blood is also varying some of the parameters in the blood, in the plasma. Not only because of the anesthetic agents I am using. I know that some of the anesthetic agents are now banned for using in animals, but the method of collecting of blood is also important because your data will be varying on that angle. So this is the diagram of some of the restainer or animal holder. Conventionally, the pharmacologists are using in lab. So it's very convenient at not that much of high prices also. Number of size it is available, and it is available for all types of animals, even in rabbit, even in dog, even in cat, even in baboons, monkeys, and obviously for mice and rat also. So this is the few snapshot of restainer, because sometimes if I am forcefully giving an injection to the animals, animals are suffering maximally. So I have to give them comfort in the restainer, because animals are comfortable in the restainer only, because my access of tail, access of thigh muscles will be very easy in that time if the animals is kept in the restainer process. So this is the most convenient method, saphenous vein bleeding methods for collecting blood from the animals, because we know sometimes we uses retroorbital plexus. We uses sometimes collect the blood directly from heart. That is also very much painful. So what is ethically correct, I will be discussing at the last, but I am telling about the process acceptable by the Government of India guidelines or as per CPCSA. The saphenous vein bleeding, the technicians punctured the lateral saphenous vein with needles at a shaped location above the knee and draw the blood into the capillaries. It's very convenient method. I also used in my postdoctoral and in my PhD research like that way. Because if I need to collect the blood multiple times in a day, this is the best method. Because sometimes we are concerning about the PK study, pharmacokinetic study, that at what different time intervals my drug is absorbing, or maybe how much is the plasma concentration. So in that time, this is the best method for collecting the blood. Very simple and convenient. And animal also is having a minimum stress. If I need, again I'm telling, if I need several times of blood with a small quantity for maybe for 3 to 4 times a day, or maybe for more than that. But this is not the perfect choice if I need only one time of blood for animals. This is not the perfect choice. What is important? What is the important skills for collecting this blood? The capillary that I am using here. This capillary has to be soaked with heparin before taking the blood. Otherwise, the blood will clot in the capillaries. I will get maybe 4.5 ml, but later on, I will not get the blood from the capillaries because the capillary is having a blood clot. So what is important skills here, that before first what I will do, I will make a punch by giving a needles, as I have shown in the third pictures. Just make a punch by giving a needles in the saphenous vein. Before that, you soak your small capillaries with the heparin. Heparin is very convenient. It is very convenient to use as an anticoagulant. Then once the punch is done, then you touch the capillaries in a specific point of the saphenous vein where the punch is done. Automatically the blood will come automatically, and it will not stop flowing. As per the requirement, I need 1.5 ml. I need 1.5 or maybe 1 ml. As per the requirement, you can just simply remove the saphenous vein as well as from the capillaries from the specific positions. The blood will stop. Very simple techniques. The next is tail vein. It is also very painful, what I believe personally. First one is tail vein and second one is retroorbital plexus. As I told, for a short-term blood collection, retroorbital plexus is the number of choice for the pharmacologist. And it is proved it is having a less pain. Initially, we thought maybe I am injecting the retroorbital plexus. It is very painful, but it is medically accepted and scientifically accepted that the retroorbital puncture is very less painful to the animals as compared to tail vein also. So tail vein is very simple. Again, if I have an appropriate choice of syringe and needles, I know that I am using from rat and mice. If it is rat, the tail is very thick. If it is mice, the tail is very thin. So depending on type of animals, I will select the gauge number. And accordingly, I can initially wash the tail with maybe for alcohol, 70% alcohol to clean it properly, to make the tail vein visible. Then I can inject it and I can take it with the vacuums, vacuoteners and all. And for the retroorbital plexus is very important. and it is very convenient. In my MPharm and PhD time also we have used that techniques. And sometimes it is recommended that you can use some of the anesthetic agents before you taking the blood from the retroorbital plexus. Anesthetic agents like isoflurane that can be given in a inhalation process. As you can see in this just in the left side pictures, the animal's nose is kept in an inhalation chamber. Actually, what is coming from there? It is coming the isoflurane, 3% isoflurane with oxygens to make the animal anesthetized, to giving the minimum pain while collecting the blood from the retroorbital plexus. And it is a very, very convenient method. It's very simple and convenient. Next, this is very important, and this is the example of cannulations, jugular vein bleeding. So blood can be collected from the jugular vein bleeding, as well as I can make a cannulation process. So suppose if I need a multiple times of blood collection in whole day, or maybe I need to infuse something for long term, maybe for saline, maybe for dextrose solution, maybe some drugs, maybe some of the protein or recombinant medications like that. In that time, what I do, I make a cannulation, as you can see it in the right pictures, that the ligature is made with the guided wire, and the guided wire will be opened through the dorsal regions of the subcutaneous side. Because if the specific wire is open in the jugular vein side, animals will having a tendency to bite it automatically. They will try to disturb it because they will feel uncomfortable. So what is happening in the lab, that the outer part of the wire, it will make a twist, and the outer part will be open to the dorsal regions, so that they don't have the access to bite it. They don't have the access to destroy the system devices of the specific cannulations. And when it is required, I can use the cannulation to take the bloods, or I can use the cannulation to induce some of the medications like that. So this is the best method if I need some of the pharmacokinetic studies, or if I need to infuse some medication to the animal's body for long-term purpose. So this is a very specific diagram video I have given to see that how the blood is collected by using cardiac punctures. This is one of our MPharm students, they are doing along with myself. This is the blood collection from cardiac puncture. Although I feel it is very, very painful, but as per CPCSEA, in special cases, you can do the cardiac puncture also directly from the heart. Obviously with the anesthetized animal, not with the unanesthetized animals. You have to feel the heart first. You have to feel the heart position first. Then you have to use 26 gauge of needle. This is a 26 gauge needle. This is myself, and one of my MPharm students is doing the experiment. And by this cardiac puncture, you can get at least 3 to 4 ml of blood from adult rat. And for mice, it is for 1 ml, almost. So 3-4 times you can get it. But one thing is important, that here in this method, so while you are anesthetizing the animals should not die. That is important. You have to anesthetize, because from a died animals, you cannot take the blood from the heart. That is important. So that is a special technique or special skills, that how much I will anesthetize. That is important. Otherwise, if the animal is dead during the anesthetic process, you will not get the blood. Sorry. So next, so till now I told about the animal handling. The two important aspects, one is giving injections for any test item or the inducing agents, and how we will collect the biological samples from the animals, especially blood, because the blood is the most difficult part. That is very difficult. Specialized skills are required to take the blood. Maximum blood is important. So here, if the ethics is concerned, I always prefer to simplify the ethics by these equations. Very simple. This is my personal feelings, what I believe. The total animal suffering in animal experimentation, just you think, in animal experimentation, the total animal suffering is equal to individual animal suffering into duration of experiment into number of animals. Very simple. I think everybody will understand that. If the number of animal is more, the animal suffering will be more. If the duration is more, that means if my study is having a 30 days of specific duration, and someone's study is having a 15 days of duration, so 30 days will be having a maximum suffering. Although I am using IVC cages, there also it will be suffer, because I need number of doses, I need to induce the medications, I can take the biological sample, so much way the animal is suffering. Okay, the question is how we can control numbers ethically. The government of India or CPCSA, as we know that the CPCSA is the ultimate authority for maintaining the ethics in animal research, they recommended 3 years. Initially, they told 3 years: replacement, reduction, and the refinement. Replacement means you cannot start the animal experimentation at the beginning. Is it? They will ask that. The committee will ask the questions. Is it that is an alternatives method? They will ask the question first. Because being a CPCSA nominee, I also understand that I need to ask fast questions. Is there is an alternative method you have studied? Or you got the same hypothesis with some alternative methods? That is the concept of replacement of the studies. Suppose I need to use rat, or maybe I need to use baboons. The ethics committee will ask you the questions: is the same study is possible in small animals like mice? If it is same, if it is possible, so why you are taking higher animals like baboons or monkeys? Why not in rat or mice? Similarly, they will ask the questions: if there is any alternative method like in vitro, ex vivo cell culture and all, has the studies done on that particular concept? If it is yes, then they will give the permissions. So ethically will come from there that I have done all the possible initial screening methods. I have done in vitro, I have done studies on cell culture, and I have the valid data in my hands. Then only I can apply for the animal models. So that is the concept of replacement. Then the question is the number reduction, because number is important factor for animal suffering. If I am taking more in number, animals will suffer more. So I have to understand that at what particular number I will take in my study. I can take 100, I can take 10 in each group, I can take 6, I can take 4. You have to understand the statistical part of this particular protocol designing also. At what number I will use, because number is important in terms of the specific animal suffering. Okay. And lastly, the CPCSA also recommended one more R in the last time, that is the rehabilitations. This is the question of ethics. It is not like that once the experiment is done, you can throw the animals outside. Not like that. So what is the meaning of rehabilitations? The animals, if it is not sacrificed in the study, they has to give freedom for food, freedom for their common environment and all, and you have to rehabilitate them for their life, till their life. That is the concept of rehabilitation. So that was the fourth R that was introduced in last few years by the CPCSA. So first of all, I have to think, if it is a question of ethics, I have to think at what number I will take. I can also take 1 in each group, but is it statistically valid? No, because if it is 1 in number in each group, statistically is not valid. So ultimately my study is waste. My study is useless. That means the animal experimentation is useless. Why you are doing that? So you have to understand the importance of number. At what minimum number I can take. You have to take minimum, not maximum. You have to understand that to give a valid conclusion, at what number I can take according to my designing of the protocols and everything. The next is the duration. The animal must experience only the minimum pain or brief discomfort when they are used in research. Each and every step, whenever I am giving injection, whenever I am taking blood, I have to be very concerned about the pain, what the animal is getting it. Why it is important? Not only what I believe, not only in the ethics purpose, but as I told that the collection method, animal care, also influencing your data. That is also important, because if the animal is in stress, all the biochemical imbalance will be there in the humans or in the animal's body. You will not get the ultimate data, actual data as expected. So that's why, not only because of ethics, I will maintain the animal suffering, but also it is important to get a very good scientific outcome in the ultimate data. So to control the duration of the experiment, I have to understand the endpoint analysis. I can give a conclusion of a study by doing 8 days of experiment or maybe 1 month of experiment. So what are the difference? Is it the conclusion coming in 8 days is not sufficient, is not significant? If it is not, then I can go for 30s. But why I'll go for 30. You have to justify that. Because duration, if it is more, animal suffering is more. Whatever you are telling, you are giving the specific freedom for the animals. You are giving a very comfortable environment with RO water, heavy specified sterile food, with an ventilated cages and everything. But even that also, the animal is suffering. So that is important. And the last most important thing is that individual animal suffering. How I can control individual animal suffering? Suppose in my lab, suppose I'm giving the example in my lab. In my lab, some student is very good in animal handling, but some student is not good in animal handling. The student who is not good in animal handling, he need to do the experiment. I don't have any options, because it's not like that. Being a teacher, I will say those who are good, he will do for him or her. Not like that. He or she has to do it. I know that if she or he is doing the experiment, animal suffering will be more, because he is not good in handling. So ethically, what I need to do, that I need to send her or him for some training, because he or she needs attitude or personal skills by doing some training. That is important. Only because of training, only because of skills, I can control the individual animal suffering. So see, in industry, I know in CRO, if a person is very good in blood collection, every day he will doing the same job, just to give the minimum suffering to the animals, because he is very good in that. But he is having skills of blood collections. Someone is very good in giving IV injections. That person is doing every day, because the company or the team leader will not say other will do for that, because he knows if other is doing the same job, the animals will suffer more. So that's why I'm telling the skill how much it is important. So if somehow it is not possible, I can send a person for training, so that he is becoming the skill, he is having the skills, so that he can give the minimum suffering to the animals. So these equations, I believe very just from my heart, that if I am having ethics in these 3 points, that total numbers, durations, and individual animal suffering. So before I start the animal experimentation, I need my personal skills, attitude of animal pain, that I think that if I am giving an injection, animal is also suffering, he's having a pain. It's not like that I have to give an injection and I will give it without anesthesia. Not like that. You have to see the protocols, you have to see the guidelines, what they are telling. Maybe in some studies, some of the anesthetic agents are interfering in my data. So what alternatives I can make it? At how comfortably I can give injections, how comfortably I can take the animals' blood collections, how comfortably I can euthanize the animals, sacrifice the animals. Euthanasia means the animal death with minimum suffering. That is important. And what method it is given by the CPCSA, that is important. So this equation is very important. What I believe, the total animal suffering is equal to individual animal suffering into duration into numbers. So if you need to thought about ethics, you have to thought these 3 points, as I told. Duration and number, I can control it with the statistical methods, and maybe for the protocol designing and all, because duration is very important. At what duration I can give a valid conclusion, that is important. Okay. And lastly, the individual animal suffering depends on your skills, your attitude, your personal skills, attitude, and for that you need a training. And that's why I thanks the organizer, that everybody, I know that for a biomedical scientist nowadays it is a very government restriction that we cannot use the animals and all, but this type of workshops or maybe for the webinars is helping the students to understand that what are the ethics, what are the handling process and all, that will benefit in future also. So lastly, this is my last slide, that personal care and hygiene is very important in animal house. You know that in animal house, as per GLP and ALAC or CPCSA, in animal house, mobile phone is also restricted, because the radiation is also affecting the animals. And if the radiation is affecting animals, your data is also affecting. Okay. So a very good personal hygiene is also important to maintain in animal house. And also obviously in the microbial safety, as I have seen here, this is my pictures in my postdoc, that every day we are required to maintain the microbial safety of the animal house. Every day You keep the petri dish and check it. What are the microbes present outside? Even though it is IVC, but even though it is IVC, animal are inside. But then also I need to maintain what are the environmental microbes are present. Okay. And this is the pictures in the top that doing some surgery with number of protections, number of personal care and hygienes, and the animal attendant. This is some of the attendant in my time. So how they are cleaning the animals' cages and all, and how they are maintaining the hygienicity and all. This is very important because that is also important in terms of ethics, what I believe personally. So this was my last slide. Thank you. And if someone have any questions, you can ask me. I'll be happy to answer as per my knowledge.
Thank you very much, sir, for sensitized us regarding the animal experiments, animal handling and care. So I think all the participants have learned a lot from this presentation, and in future also we organize this kind of workshop or webinar so that we can informed regarding this kind of animal experimentation, animal use in experimental pharmacology. And thank you so much, sir. So I am requesting the participants, if you have any questions, any doubt regarding today's session, so you can write your question in chat box.
So what I believe personally that maybe it's a e-workshop. I know that the skill cannot be possible by just observing the videos and all, but it needs a special hands-on training. So if it is possible, I think all the faculties in Adama's University, they can arrange that type of workshop also.
Sure, sir.
Outside, that means excluding from the specific courses and curriculum, additional to that. Because
Yes,
I know that in course and curriculum, we don't have that much of skill development program for the students, especially concerning to animals as per the Government of India rules. So that is also important.
Sure, sir. Sure. In future, I hope this kind of training or workshop will be helpful for the research scholar as well as students also. So I think there is no questions from the participants. So one question is there. So is there any statistical method to calculate the minimum numbers of animals required for a study?
Yeah, it's very good questions. It's asked by Anusha. Okay, it's very good questions. I also thought whenever I have designed some of the protocols in my PhD also, I thought about that. So see, as per the common concept, if it is a very conventional study, it depends from study to study at what type of study I am doing. So what type of variables I have, what type of degree of freedom I have in my experiment. If it is a very conventional methods, like I am evaluating some drug for anti-diabetic activity. Okay, I'm a very common example. Okay, so we know that every time we uses two doses. One is low dose, one is high dose. Yes or no, Anisha? Yes. So I think so that every time we have a concept that we uses low dose and high dose. Depending on LDPP study, we do like that. So in that case, it is expected and it is accepted by the statistical method also. A minimum n is equal to 6 is acceptable. But recently I got a comments from some of the journals. They told at least 3 dose level is expected. That means one low dose, one medium dose, and one high dose, not 2. If it is like that, so if my designing in like with the 3 dose level, I can take n is equal to 4 because ONO, ANOVA or analysis of variance or direct t-test or Kruskal-Wallis test, whatever you told, if the dose level is 3, n is equal to 4 is acceptable. But if the dose level is 2, then I need n is equal to 6 minimum. If it is more, it is better. But minimum you have to take 6. But if the dose level is 3, I can take minimum 4. So that is the standard method. But even again, I am telling it depends from study to study. What are the variables? What are the degree of freedom in the experiment? What are the variations in individual animals? That is also important. And what are the variations in other factor also is important. And one thing I forget to discuss in the slide that is important, that nowadays the conventional animal method is not that much of important because everybody is thinking in the worldwide humanized animal models. So what is the meaning of humanized animal model? That means I am implanting a human cancer cell to the mice. Then I am doing the experiment. So that will be more having a more success index. Otherwise, if you take a mice specific cell and doing the experiment in mice, maybe the etiology of that tumor or cancer is not same with the human tumor or cancer. So nowadays, the worldwide, there is a trend of doing a humanized animal model. It's very interesting and very scientifically validated nowadays. So humanized animal model. So in that model also, the number is having very important. At what number I will take? What Anusha asks is a very important question and very common to all pharmacologists, that every time we are having a question from the ethics committee that at what number I will take it. But conventionally we take 6 if it is 2 dose, but if it is 4 dose, or sorry, just if it is 3 doses level we have taken, I can take it 3, not 3, I can take it 4 for doing the ONO ANOVA test.
One more question we have, that how can we select the 2 doses extract for animal studies? That means the plant extract he is asking.
No, as per the common practices, because you cannot take the doses arbitrarily or randomly. You have to do number of toxicity tests, especially on LD50 test on mice. There's a guideline as per OECD. LD50 studies number 425, 424 and all. So if you got the LD50 value in your hand, so starting dose for that we know that the conventional method, what we practice in our lab also, that 1/5 and 1/10. 1/5 and 1/10 of LD50 value will be the starting dose for initial evaluation systems. But you cannot start randomly.
Sir, no, sir, there is no questions anymore. So personally, I have one question regarding that you have discussed that if we provide the homogeneous environment to the animals, then we can accept a 90% success rate that is equal to the human studies. But if we not providing or provided the all the environments perfectly to the animals, can we correlate that we can get the 100% result in humans?
No, see. Not only the variations will not come from the case-to-case variations. As I told in the WHO data also, it depends on what method you are collecting blood, how your animal is maintained. It's not like that, because this is one of the important parameters. I am giving a very equivalent environment to each and every case. So the question is why we are using the inbreed strain of animals? Because inbreed strain of animals variation is very less. They are identical. Because at the end of the experiment, I need to compare control versus test, control versus standard. So if all the animals are not same, if they are not identicals, how I will compare? If the animals are not maintained in an equivalent environment, how I will compare? Okay, so whatever you told, that I'm not telling that only by purchasing an IVC, the success rate will index or success rate will increase. Not like that, because there are so many factors. This is one of the important factors. Got it?
Yes, sir. Thank you.
So that is one of the important factors, but there are so many factors to consider to increase the success rate. And that's why I told, because all the animal model is having a first questions. Is it the disease model is same with the human model? Is the diabetes I am producing in animal, is it same with human diabetes? No, first question is no. If the breast tumor I am making in animals by giving a carcinogens, is it same with the actual human breast tumor? No. That's why the ultimate success rate is less. So what the proposal is, you have to develop a humanized animal model. That is the worldwide it is going on nowadays. So I am implanting some gene in mice. So that gene is responsible for human particular disease. So that is the model concept of humanized animal models. Or maybe I am implanting a breast cancer cell to a mice. That means I am implanting a human breast cancer cell to a mice. That is the meaning of humanized animal model. By this way also we can increase the success rate. Got it, Sushmita?
Okay, thank you, sir. Thank you. Okay, I think there is no more questions. Again, so I am requesting the participants, if you have any questions, you can put the questions in chat box. Okay. Okay, sir. I don't think they have any questions. So from the behalf of School of Medical Sciences and Department of Pharmaceutical Technology, I am sharing the small token of gratitude for giving us such a wonderful presentations and enlightening us. So this is a certificate of gratitude, sir.
Thank you so much. And thank you for inviting me, obviously. And as I believe that it's a very good initiative by Adamas University that they thought about it, that to develop some of the skills, obviously by giving an e-workshop, as I told because whenever I got the invitation, I was thinking that it's a very good initiative taken by Adamas University. Because in pharmacology, our students are, I'm not telling it's suffering, but they need this type of workshop. I'm not telling they are suffering, because skills can become anytime in the students. They can learn by observing the videos also. Sometimes it is possible. But if they get the option for handling, option for doing some of the experiment, they will be more understanding the concept of the skills and everything. But yes, there are some exceptional cases. Some students can get the concept by visually observing the method also. That is important.
Okay, sir. Thank you, sir, for joining with us. And now I'm requesting the participants to fill the feedback form, which I have shared in chat box. So now it's an immense pleasure to deliver the vote of thanks for this event to all the dignitaries assembled here. And we would like to thank our senior professor, Dr. Subrat Kumar Bhattamisra, who honored this function with his welcome message. And we would like to thank you, our Honorable Associate Dean, Dr. Sajal Kumar Jha, and respected HOD, Dr. Sanjay De, for their immense support for smoothly conducting of this event. And last but not the least, I would like to thank all the participants for making this event a grand success. Thank you all once again.
Thank you everyone.
Thank you. So with the permission to our Dean sir, now I am ending this session.